Good afternoon, ladies and gentlemen, our guest speakers, teachers, colleagues, and my student. A very warm welcome all of you at our third online webinar, and good afternoon to our audience remaining as online. First, may I thank our speaker for taking part in this event. The quality and caliber of our speakers this year in ELISA Summer School is outstanding. I also want to thank all of you for connecting, and I hope you are looking forward to this discussion as much as I am. So I'm Dr. Engineer Rawinet Hene, Associate Professor and Student Space Center Director at ELISA Aerospace Engineering School. I will be your moderator for today. Before beginning, let's take a moment to introduce our special guest speakers. So Muriel Hooghe currently works at the Luxembourg Space Agency, where she follows aspects related to space safety. Muriel represents Luxembourg at the European Space Agency and the European Union boards on space safety matters, and is involved in the development of the space ecosystem in Luxembourg. So prior to this, she worked at SES, where she had roles in spectrum management, Contingency and Transition Planning, and Flight Dynamics. Muriel holds an engineering degree from the University of Brussels and a PhD in physics from the University of Nice, Sophia, Antipolis. She had also taught space project management at the University of Luxembourg since 2019. In 2023, Muriel was selected as mentor of the Program Space for Women of the United Nations Office for Outer Space Affairs. So today there is two parts. Space safety aspect during 30 minutes, and after we have Bob Luz for 15 minutes also with us. Thank you for joining us, which is the responsible for talent development at the Luxembourg Space Agency, and she will present opportunities in the Luxembourg Space Sector. So I hope the discussion on today's webinar will be great and successful. Hope all of you will cooperate at the same time, enjoy the conferences. I am sure this webinar will be profitable and fruitful for everyone present here. We will take also all your questions throughout the webinar, so please feel free to type them into the chat box. And now let's start. So dear Muriel, the floor is yours.
Thank you very much, and thanks for the very kind introduction. It's a pleasure to be here. Thanks to all the ones who are attending and taking a break in this middle of the summer. Let me share a short presentation I made. And let's hope this all works. Can you see? Do you see the
till now, no.
Okay, it's telling me it's showing them, but let me try again.
Mm-hmm.
I'm getting a message that it's coming through. Do you see it full screen, or do you just see a bit of it?
So for me, I can't see, but there is a message that we can see. Yes, I can see.
Okay, excellent. Okay, I'm not sure what you see, but let me know if there's any problem, because it's very strange. Excellent. Okay, well, thanks for being here. I'll start with about half an hour on space safety, which is my main topic of interest, and then I'll hand over to my colleague Bo Bilos to discuss job opportunities and talent development in Luxembourg. Just a quick overview of what I'm going to be presenting. I think Hannah did a great job of presenting me, so I'll skip the slide about me, but it's going to be mostly about what's space safety about, because we hear a lot of things, so we'll just do a little overview of what different topics are covered when we speak about space safety, and we'll see why it's important, and then we'll have a look at what is Luxembourg actually doing about it. How can a small country like Luxembourg actually tackle this huge topic related to space? But before that, I'll do a quick overview of what we actually do at the Luxembourg Space Agency. So this is a slide about me. We can skip, but so what is the Luxembourg Space Agency? Basically, space events started in Luxembourg in 1985 with when a small startup decided to launch a satellite. This startup was called Société Européenne des Satellites. It was later to become SES. It's now one of the largest satellite operators in the world. So from the small country, they set up facilities. They now have more than, I think, 20 antennas on their ground. So when you actually fly over SES, it looks like this huge facilities. So that's basically where the notion of space started. And it took another 20 years for Luxembourg to actually join the European Space Agency and become a full member of ESA. Following this, there was the first space policy in 2008. And then the next big development was the enabling of the space resources utilization. Basically, Luxembourg set up a framework for the use of space resource, so anything that's related to mining in space. And this gave a new impulse to the space industry with the development of the Space Resource.lu initiative in cooperation with the European Space Agency. And then in 2018, the Luxembourg Space Agency was created. And in just last year, we presented our national strategy. And what do we do? So we're not the typical space agency like when you think of NASA or big agencies like the CNES in France or DLR in Germany, in the sense that we don't really have our national scientific missions. We're more like an economic development agency. We're a relatively small agency. We're an entity with about 20 people. And we focus on creating economic growth through the space sector. So the idea is to help the creation of jobs, help the creation of revenue through the development of companies that will develop in Luxembourg. So we'll work on the enhancement of the space ecosystem in ways through financing them, but also through helping them set up, when the startup wants to come, how can they install, where can they set up their offices and things like that. We're also there to enable connections between companies from the space sector and areas that don't necessarily think that the space sector can help them. And the Luxembourg Space Agency can be there to do this bridging between the two. We're also occupied with local talent development, but I'll let Bo discuss this in more detail later. And then we're here also as representatives on an international level when there are economic missions in other countries. We will either have representatives of Luxembourg Space Agency or representatives of our ecosystem join the economic missions to represent Luxembourg and our activities abroad. So that's for the Luxembourg Space Agency. But now to the heart of the matter, space safety. What exactly is space safety? What is it about? We'll keep it relatively simple. Space safety is about protecting life and infrastructure, both in space and on Earth. If you attended last week's seminar, you probably heard how our everyday lives are actually not governed by space, but we actually use space much more than we think. When we use the GPS to go somewhere, when we're listening to weather forecast, in communication, even in agriculture and e-health, space has become omnipresent in our everyday lives, and keeping space safe has become really fundamental for life on Earth. And what are the threats? Because so far so good. We're using GPS, we're using satellites on a daily basis. So where's the problem? We basically group the threats in three groups. One is space debris, and the accumulating number of objects that are in space. You've probably seen the graphs. It should show up on the slide, actually, and if it doesn't, there it is, of the growing number of objects that have been launched into space and that are staying into space. Of course, there are all the payloads, which are actually the active objects that are used on a daily basis. But some of these objects are also old satellites, remaining rocket bodies, satellites which have, are not used anymore, who have broken up. And these are becoming endangered. The number is just growing at a very high rate that you can see on the graph. Basically, on the graph that you see on the slide, only the dark blue objects at the very bottom here are active objects. With the number of objects in space, and mainly the uncontrolled objects, there's the risk of successive collisions, leading to this uncontrollable chain reaction that you may have heard of as the Kessler syndrome, sorry. If this happens, there's a high risk of damage being done to operational satellite, which per se is already a bad thing, but also of damage being done to the International Space Station, and there are astronauts in the International Space Station. So we're actually putting lives in danger with the number of debris in space. And then there's one other effect of these objects, is that it's basically congesting space so much that it's putting in danger future missions. So what we have now is viable so far, but what about new missions? What about countries who haven't had a chance to launch objects yet, but who may want to launch objects later? Will they have the same fair access to space as spacefaring nations have had until today? So it's something to think about. This growing number of objects is growing much too fast, and something has to be done about it. Before looking at solutions, let's look at the second threat, which is space weather. Space weather is related to the activity of the sun, and periodically there are geomagnetic storms that come in form of solar flares or coronal mass ejections. These are basically bursts of charged particles or high energy particles, such as photons, that can damage operational satellites. They can cause disruptions to these satellites. They can cause electromagnetic discharges, which is basically like a short circuit on board of your spacecraft. And you know that once your spacecraft is up in space, it's very hard to go and repair it. These storms can actually be so strong that they can also cause disruptions to communications on Earth. It's much more rare. The last big one was in 1859. There was a major failure of the telegraph systems due to a solar event. You think, okay, 1859, it's a long time ago, but still, it just shows how strong these can be. Until today, it's really hard to predict these events. A lot of research is still being done, and we'll see what else can be done to protect our assets and to continue investigating on this topic. And then the last threat, maybe most spectacular of all, but most unlikely, would be the impact on Earth of an asteroid. We know that this is the type of event that caused the extinction of the dinosaurs, so we see how dramatic such an event could be. For life, of course, for biodiversity, for infrastructure, for economics, but just overall for our lives, which is why, however unlikely these are, we actually do take these events seriously. So these are the three groups of threats that we look at when we discuss space safety. And what can we do about it? In terms of space debris, there's three things we can do. We'll classify them in groups, like monitor, so find out what it's about, mitigate, avoid creating more, and remediate, try to remove what's already there. So we'll look a little bit more detail at each of these aspects. Monitoring is really about finding out what's up there, having a database of the objects that are there, trying to identify their trajectory so we can already know what we have. So the tracking is done until today through telescopes and radars for position estimation and for orbit evaluation. There are new projects now that are going to launch sensors into space to try and identify these objects directly from space, hoping to have more detailed info, to have also visibility on smaller objects, because there's only so much you can do from Earth. Watching through the clouds, depending on the weather, and basically just assessing the distance. There's also the problem of merging all this information, because you have images from a wide variety of telescopes taken by a large number of different companies, agencies, and bringing all of that together can be quite a challenge. So there's also a lot of work being done in terms of merging of the information from the different sources. Basically, there are several services that can help you as if you're a satellite operator to know what's happening in space. And typically what you would be interested in as a satellite operator is knowing what's going around my satellite. In the United States, there's what we call the 18th Space Squadron, which is part of the US Air Force that actually gathers information from telescopes around the world. There's a similar service in Europe called the EUSST that's working with European data. They all have their own database, and they all act as a public service. So all you need to do is sign up as a satellite operator, and you actually get this data for free and this information for free. There's also private companies that are giving sometimes more advanced, different information, and that's developing very fast as well. To give some example, ExoAnalytics, Share My Space is a French company, North Star is a Canadian company with an entity developing in Luxembourg. All these companies are developing similar services and tools to assess what's in space, what's going around operational satellites. That's for the monitoring. Next is mitigation. Once you know where objects are, you can try to avoid collisions. If you see that two objects have orbits that are going to cross, that there's a collision risk, as long as you can maneuver, of course, which is the case for active satellites. It's not going to be the case for debris, typically old rocket bodies or dead satellites, malfunctioning satellites. So when available, you can maneuver to avoid a collision, and that's going to be really important to avoid creating more debris. It's the same actors who are actually monitoring the sky, who are actually proposing services to estimate the risk of collision, and they can also help with the estimation of collision avoidance maneuvers. There's also some extra ones that are working only on developing tools to do this. But there are other mitigation actions that can be taken, in the sense that when you finished your mission with your satellite, there are some regulations as to what you should do with the satellite. Satellites that are close to Earth should be deorbited by bringing them back into the atmosphere so they can disintegrate in the atmosphere. Satellites that are used in the geostationary ring should be brought into what's called a graveyard orbit that's above the geostationary ring so that they don't interfere with the satellites in the geostationary ring. So these are actions that can be taken to avoid generating debris in areas that are highly used by payload satellites. This is actually the responsibility of each operator, each manufacturer, to actually have satellites that can be deorbited, to actually keep some fuel at the end of life to do this deorbiting. It's also the role of governments, international organizations, to actually set up the framework for this. So I think you had a webinar on space law, and I think this is typically what's taken into account in the space law is how it, or part of what's covered by this is what's to be done with satellites at the end of their life. And it's really important. Right now, there's not a system, there's not an ideal full framework for space traffic management, but it's being worked on, it's being developed, and there's really a lot of work going into that today. And there, next slide. And then the third topic that to work on space debris problem is remediation, in the form of really going up there to remove the debris. This is a difficult task for all the small debris, but there are some very big debris that are the source of most of the collision risks that are observed today. And there are a few projects. There's still just a few, but it's a beginning. ESA has one going on. There's one with JAXA, the Japanese Space Agency, being developed as well, for the removal of a big object in space. Once this has been demonstrated, maybe there's a chance that it can continue. There's also projects such as preparing satellites so that they can be more easily deorbited at end of life, having little plates so that they can be magnetically hooked at end of life to easily deorbit them in case they wouldn't be able to do that on their own. OneWeb is doing that, for example. Another form of remediation is actually extending the life of a satellite. Right now, a satellite can only live as long as there's fuel on board to operate it. If there's a way to extend this, to bring back some fuel, or to piggyback with some additional fuel tank, you can extend the life, which actually means not sending an additional satellite. So this is another form of remediation. There are also missions to look at this type of solutions. And then in the longer term, there's everything that's related to in-orbit manufacturing, which is, you can think of almost as in-orbit recycling, reusing old satellites to try and maybe rebuild some parts, or if there's a malfunctioning, being able to fix them in orbit. So all these elements, we're still far away from that, but we're getting there. It's part of the projects that are being developed at ESA, NASA, and other big agencies. And commercial companies are very active in helping with that, or at least participating. In terms of space weather, it's a bit more complicated because we're still having trouble. We're still in the process of developing models to understand fully when the weather phenomena are going to happen. There are some models that are developed. There's some measurements that are being taken at different points in space, but it's still not quite enough to really be able to anticipate problems. So this is really ongoing research. There's a lot being done. And yeah, there's still a whole lot in the pipeline now at this level in terms of protecting assets, forecasting events. There are agencies in the US, the NOAA, that's working on this, EUMETSAT in Europe. There are some private companies working on that as well. But here again, the solution is twofold. One is research and development to be able to model, forecast, and then once you understand this better, to actually protect the assets. It's already partially being done with shielding effects on the satellites, but that's not always enough. So still work in progress on that matter. And then in terms of planetary defense, there's a huge amount of work being done in identifying all objects coming close to space, identifying everything, computing the collision probability with the Earth. And really, ESA is doing a continuous job of identifying this. And as soon as a new object is detecting, seeing if there's a risk of collision. Right now, there's no object that's at risk of collision with the Earth. There is an object coming closer to Earth in 2029, about 30,000 kilometers. So it's an interesting event. And these events where objects are coming closer are actually used to understand these asteroids better. to understand their properties, and to understand if anything were ever to happen, could we deflect them? There's a mission called DART that you may have heard of from NASA that tried to deflect an asteroid. The collaboration with ESA is going to help go and measure the properties of this asteroid, how much it was actually deflected. So there are lots of, again, research going on here and continuous monitoring of how Earth can be protected from asteroids. So these are the three big threats to space safety and what can be done. And then what can be done, what can we do as Luxembourg, which is a small country, to actually contribute to this space safety? So as I was mentioning in the very beginning, in 2022, the Luxembourg Space Agency set up their space strategy. This space strategy is basically centered around sustainability. So it has 4 pillars around economic sustainability, sustainability on Earth, sustainability in the use of space resources, and then the sustainability in space, which is the pillar that we'll be interested in here, and which is directly linked to space safety, because by assuring sustainability in space, we're actually directly working on space safety. And our contribution to space safety is basically in participating at ESA Space Safety Program, participating as a member in developing the themes that we want for the research in the future, but also financial participation in some projects. As a member of the European Union, we're also working together on space traffic management regulation, and we're part of the EU SST services development from the European Union. And then more locally, we're actually developing our ecosystem, helping companies that are in line with our strategy. So we really, when we help companies develop in Luxembourg, we really focus on seeing that their mindset is the same and contribute to sustainability in space. And in right now we have at least 4 companies that are directly contributing to space safety. One is North Star, who's we mentioned them earlier. They're going to send a constellation of satellites with sensors to contribute to space situational awareness and identify debris in space from space, which is something very new. There's an entity of Clear Space, which is a Swiss-based startup that's setting up an entity in Luxembourg for in-orbit servicing. So we'll be refueling a satellite in space for an to extend their lifetime. LMO is a company that's developing software also for space situation awareness and to help for everything that's related to rendezvous and docking. So that's going to be able to contribute to in-orbit servicing, rendezvous and docking, and also general space situation awareness. And then Mission Space is a company that's developing space weather tools. And many of these cooperations are done with the University of Luxembourg and the SNT, which is another research organization linked to the university. So basically, the ecosystem is very interactive. They work a lot together, and it's good to see both our research and our private companies working together on these missions towards a common goal. So I'll conclude, I think almost reached the 30 minutes, by saying that space safety is really key to maintaining space sustainable. We've seen the space debris threat. With the growing number of space debris, it's crucial to ensure space and sustainable space to limit and possibly reduce the number of debris. It's going to be crucial to maintain space exploration, communication, and all other space applications. In terms of space weather, we know it's a complex phenomenon, but the potential impacts highlight the need for continued research in this field and preparedness to minimize the effect on the technologies and infrastructure that we have both in space and on Earth. And though we know the likelihood of a catastrophic asteroid impact is low, it's crucial to continue monitoring near-Earth objects to improve our understanding and their characteristics, and be ready to mitigate if there was the scenario of an impact with Earth. And with that, I'll hand over to my colleague Bo to speak about opportunities in Luxembourg.
Thank you very much, dear Muriel. So now the floor is for Bo. She is the responsible for talent development at the Luxembourg Space Agency, and she will present opportunities in the Luxembourg Space Sector. The floor is yours.
Okay, thank you. Bo. Thank you. Good afternoon or good evening. Yeah, we'll first talk a little bit about the local talent development strategy that we have here at in Luxembourg, because this is a huge part of the overall strategy for Luxembourg. As you can see here on the slide, it's one of those pillars, exactly because our main objective is to support the Luxembourgish space ecosystem and the companies and the research institutes. And these people, of course, need the right talent to work for them and to help and support them. So that's why this is such an important objective for us. Now we have a couple of initiatives here in Luxembourg. I'd just like to highlight a little bit the ones that we have for students. So first of all, I just want to mention also, as already Muriel mentioned as well, we have a very close collaboration between the companies and the university. And therefore, the university also offers an interdisciplinary space master, which is focused both on technical and non-technical aspects of the space value chain. So it's about system engineering, it's about space informatics, but also about entrepreneurship and business management. Because, of course, engineers are needed, and we see that as well within our ecosystem. I think any kind of engineers are needed also within Luxembourg. But these people, we also need people that have a more multidisciplinary background, and entrepreneurship and business management is also an important part of that. We also have another master at the university, which is focused more on space communication and media law. Also because, again, this is another big part of what Luxembourg does, where we are strong at, and which is also needed to develop. If you then look a little bit more into detail, so like maybe the next slide, I don't think, can I? Okay, good. We offer the YGTs. Those are the Luxembourgish Young Graduate Traineeships. They're a little bit similar to the YGTs that are offered by ESA, and they offer a nationally sponsored internships at ESA for up to 2 years. We launch topics every year in the summer, as we did now this year. The deadline to apply is the 21st of August, so we have now launched a new call. What is it for? It's for people that have just or will just get their master degree. So either are in their final year of their master or will start or have finished their master degree. And these you need to be either Luxembourgish or living in Luxembourg, so have a residency. And the topics that we offer every year are dependent on the Luxembourgish industry needs. So these topics will correspond to the needs of the Luxembourgish industry. If we then look at more the internships itself, so the one that I talked about before was working at ESA. The other one is working at Luxembourg and at the companies themselves. We offer a space directory, which is really an overall. I've added the link to the LSA website, so you can also see the space directory. It offers a complete picture of the space industry in Luxembourg today. It shows you all the companies that are working in Luxembourg, and also the research institutes. And there, yeah, you can see where there's potentially a match between your expertise and the Luxembourgish companies that are that are working in Luxembourg, and yeah, that it's always, they will always offer internships, and this is always a great opportunity to work for one of the companies in Luxembourg. The last thing that we also do for students is we organize students events. We have now the Space Resources Challenge. As Muriel also mentioned, Space Resources is one of those other pillars for Luxembourg. And together with ESA, we organized the Space Resource Challenge in order to have competitive teams work on a specific topic around space resources. We also organized the Space Hack, and this year we had the Space Summer Festival as well. So really to engage students, to get to know Luxembourg, to get to know what we offer and what we can give to the students. So yeah, I think this is a bit the overview of what is happening in Luxembourg, more towards the companies and all the job opportunities. So yeah, thank you for giving me the floor to give this information to the students.
Thank you thank you very much for this advice for our student. Really is very interested for all of our students. There is a lot of master's degree internships. For example, the Space Hack is very interested. Also, the White Cities, we have time also to participate. So we hope also to have a partnership between our engineering school and Luxembourg Space Agency. Thank you very much. I really want our student and the public present here with us to interact in this topic and take the opportunity you have with us today. So I start by the first question. I don't know the first question. So how, sorry. What role can artificial intelligence play in space surveillance and space security?
Yes, I can take that one. Can you hear me?
Yes.
Yeah, I wanted to stop sharing so you could see, but I don't know if it worked. But anyway, yes. I think there's several ways. It's used a lot to recognize satellites. Basically, they use it for machine learning to recognize satellites so that they can take several photos in different conditions and teach the system using AI to identify an object with a limited number of elements. So when you're far out of space, the sun is going to illuminate your satellite from a given direction, and in different times of day, it's going to be different areas. And you can actually teach your algorithm to recognize your object. And the AI is going to help you also to redo this with a different object, because if you have to educate in each case for with long campaigns, it's going to be it's not going to be efficient. So AI is actually used to transition, both to teach it to do the machine learning the first time, and then to move from one object to the next. It's also being used in terms of object recognition, which are not just satellites, just stars and identifying areas in space. So those are the quickest areas I see where you have use of artificial intelligence in space situational awareness, but I'm sure there are many more.
Thank you. Second question is for Beiluz. I'm pursuing my master in ESM. I'm from India. I would like to know if I can also apply for UGT.
Hi. Yes. So this is this is an internship that is offered at ESA. There is a requirement that people are coming from or have a nationality that is from one of the ESA member states. or cooperating states. So for India, this is, I think, not possible except for the case that you already have a Luxembourgish passport. Then it is possible, but you need to either be a Luxembourgish national or have a residency in Luxembourg, with your nationality being one of the ESA member states.
Thank you very much. So I want to ask one question also. There is a lot of frequently asked question on space debris, like, for example, how does the European Space Agency plan to remove space debris from orbit, and how do robotic spacecraft protect themselves against space debris?
Yeah, that's a good one. So in terms of removing space debris, right now there's a project to remove a big debris. So it's you can have a look. The company that's that's working in collaboration with ESA to do that is called ClearSpace. They're basically developing four arms that will go around the debris, and that will basically push it back through into the atmosphere to disintegrate it. So they're going to be catching an old ESA debris, a leftover of a rocket. So that's the plan for the big debris. There's a similar plan with JAXA with a similar design. I think and this is the kind of solution that will work for large debris like this. I was mentioning that there's actually a list of the so-called most dangerous objects that cross highly used orbits the most often. And these are solutions that could be used for this. But what's more important is this is actually enabling new technologies that will help us do this on a more systematic level. Because we have constellations that are being launched now, such as the Starlink constellation, where they know by design that they have 10% failure on their satellites. Now, in most cases, these satellites are deorbiting on their own. They're not that high, but it does take some time. And at some point, there may be a need to do this faster. There's also going to be a need for satellites that are higher, that will take much longer to disintegrate, to go and remove them, or at least reduce their altitude to evacuate them faster. So all these technologies are actually going to help do this in a more stepped way and bring these technologies closer to something a bit more systematic. I think until there's actually a law that forces you to do this, it's not going to be a systematic action. Until there's going to be a penalty because you don't deorbit, it's only going to be done by agencies who want to show that they can do it, or who are actually afraid of a liability in case there's a collision with their object. So there's this evolution that's needed in the way we think, in the way we have the regulations. And then the other part is actually having on board a system that allows you to do deorbit, because we need to solve what's there now, but we need to make sure that we don't make it worse, so that anything that's launched today should have their deorbiting capability, so that it can be deorbited at end of the mission.
Yes, exactly. Thank you very much. I think also that there is a reason to be hopeful in this subject, because when we compare, there is only between 15 and 30% of the satellite at low Earth orbit, so all of which require active disposal, as they will not re-enter and burn up naturally anytime soon after their mission ends. So we need just to apply the same effective thinking to all orbits, I think.
Yeah, I think we can be hopeful, because I think there's really the conscience is there. The coordination is going to be difficult. We're not all going to find the same solution when we see it, whether it's at European level, at American level. everyone is contributing, but we're not on a consensus based yet. But slowly we're coming, I think there's a realization that something needs to be done, and that's already a good thing. And even with small different solutions, it's going to build up into something that helps us move forward.
So space has the potential to inspire, to motivate, to push us, to break down barriers. We have many reasons to believe we can work together to find solution to the problem of space debris and achieve a better future for everyone. A very nice afternoon, dear experts in the front. We thank you very much for your time and for your availability for us today. Very important information. Thank you also all the public present today. I wish you all a very nice evening, and see you very soon in our next and final session in August of the conference series next week with another topic. We will speak about the opportunities to become a space entrepreneur in Europe and how to strategically navigate your career and your thinking process to get there with Natalia Lemarquis, the CEO of IT Design. Thank you very much again, and have a nice evening.
Thank you for the invitation. And thanks to everyone who attended.
Thank you very much. Bye.
Bye-bye.
Bye.
Bye-bye.